the first day afternoon session of the 61st Conference and Annual General Meeting. First, I would like to acknowledge our platinum sponsor of today, Concrete Ontario. And I would also like to thank all our sponsors, the bronze, silver, gold, and platinum sponsors. You can find their names in the conference booklet. And again, I would like to encourage you to visit the virtual booths that are available through the attendee hub throughout the day. I thought we had a good session this morning. The presentations were pretty interesting. And, I won't go through what I said this morning. So we'll just get on to the presentations of the afternoon. We have 5 presentations planned for this afternoon. And our first presentation is on asset management, levels of service. The speaker today is John Tarantino. John is a professional consultant with a proven record of 25 years in developing visions and strategies for the successful design and implementation of asset and infrastructure management and information technology solutions. John has had a distinguished career in providing a range of services to municipalities. In 1998, he established an Ontario Municipal Partnership that brought together municipalities with a desire to share in the collaboration of deploying municipal web-based solutions. In 2001, John brought together a number of municipalities to apply for the Ontario GeoSmart funding. In 2017, he was instrumental in establishing a partnership with the Ontario Good Roads Association, Ontario Recreational Facilities Association, and 15 Ontario municipalities collaborating in an asset management initiative. Welcome, John.
Thank you, Salim. So I'll start by sharing my screen here. So I hope you folks can see my screen and we're good to go.
Yeah, we're good, John.
Awesome, thank you. So thank you very much. What I'd like to do is over the next 20 minutes or so, share with you some interesting initiatives that are going on throughout the province of Ontario. Some of the slides might be a review for some of you folks, but towards the end of the slides, I think you'll find some interesting information that hopefully you can take away with you. So to begin with, asset management resources that are available to the various municipalities, and just a little bit of an overview. So MFOA for the past 3 years has been offering a product called AMP2. About 300 small to mid-sized municipalities have participated, and it's to help them to review their asset management strategy. ORFA, which is the Ontario Recreation Facility Association, over the past 5 years has been helping their members collect facility and park information related to asset management. The other are a few of interesting type of relationships. As part of the asset management strategies, municipalities are going to have to collect information about hockey arena facilities and so on. So the US Ice Rinks is an association specifically designed for that. World Urban Parks, a lot of good information about managing parks throughout the world. And then there's a few other resources that are available to you. So the reason we're talking today is because of the regulation. And although the regulation has been pushed back, as you can see, some of the dates have been pushed back, the needs and wants are still there. And a number of the small to mid-sized municipalities are proactively working towards achieving these deadlines. So although it's been pushed back, what you'll find is that every municipality that's applying for funding, whether it's the treasurer, whether it's the CAO, whether it's the director of public works or engineering, more and more requirements are there to fill in and to validate that the town or that the city is moving forward with the asset management strategy. And so these are some of the new requirements when it comes to applying for funding. So as part of that regulation, there's a number of components that the province has already defined, right? So the scope and the quality of the asset, whether that level of service is associated to the community or from a technical perspective. And so from a community, the ability to visualize, the ability to inform them of what is going to take place. And from a technical perspective, the understanding that the approach towards asset management is consistent and that enough technical information is brought together to allow you to do that. And so there's a couple of key components, right? One of them is the larger the municipal population is, the greater the accountability. I believe that there's a threshold that anything over 25,000 population, there's greater accountability for it. And so these are words taken right out of the regulation, right? From a customer perspective, the municipality must prove that the level of service provided is reasonable under the circumstances, given the volume, character, and location of the asset. And so you can't avoid ensuring that the municipality is making that information available publicly. From a technical perspective, what's the pavement condition? Water boil advisories, number of properties connected to water, resilience to the 100-year storm. Again, the larger the population, the more these requirements are being put into place. So what do you need to take into consideration? When you're talking about asset management and level of service, you know, in the middle of the diagram, you see that investment is the first aspect. What's it going to cost? Can you afford to do it? Based on the cost, what level of service can you adopt? Can you ensure that you're delivering on? And ultimately, what's the risk of both the level of service that you're adopting as well as the investment that you're willing to make? And so with that at the core, around that, you know, you've got to start with collecting your inventory, and not just collecting at once, but there's going to be requirements for maintaining that inventory on a yearly basis. What are the inspections that are needed to ensure that the work is being done properly? What are the work orders that are required once the inspection has failed? What's the risk assessment to those work orders? Can we then create enough of a budget and the prioritization to ensure that the work is done? And then what inventory do we need to replace? What inventory do we need to maintain? And all of this information is multiplied times 5 or 6, because you have to do this for every asset that you own. And so where does a municipality start? Well, you start with a policy statement. And you know, this is an example of what a policy statement could look like for roads. But there's an interesting aspect to this. There are some municipalities that would just cut, copy, paste and say we've established our policy statement. There are those that actually take the time to articulate what it is and what are the ramifications of adopting that policy. So step number 1, you establish that policy. As part of that policy, you want to also make sure that you can visualize things. So from a customer level of service, can we see where the inspections are? Can we see where the work orders? Do I need to contact someone within the town to access that information? Or can I just go to a portal and view that? From the technical perspective, which is the internal side of it, you know, what level of service do we want to achieve? What are the life cycle events? What are the costs? Now you're getting into more of the engineering side of it and more of the actual cost and finance associated to it. So a level of service component really requires three key aspects. The inventory portion of it, and again, that inventory talks about your water main, your roads, your sewer, your bridges. The life cycle events. At what point are we going to replace, resurface, rehabilitate, reconstruct? What are the different financial costs associated to each one of those tasks? And then lastly, what's the risk of doing or not doing something? So when we talk about inventory, the struggle is real. Those of you that are trying to collect data, manage the data, you understand the challenges. And so to add more to that, what we have noticed in reviewing a number of asset management plans and so on is the lack of standardized benchmarking. So what do we consider a class 1 road? What are the different types of road? What are the different types of material? How are we using those words or those descriptions that can be used across the province? From an inventory perspective, accurate and detailed. How much is enough? How much is too much? And so by going through your policy, by going through the requirements, you're going to be able to identify these are the specific fields. As an example, are you starting to collect information about whether that asset is part of your energy consumption? And so along with that, then you get into your life cycle events. At what level do we reconstruct the road? At what level do we do shave and pave? At what level do we do the various tasks associated to it? And so you have to collect this information and you have to standardize it and normalize it, whether it's your road, whether it's your building, whether it's your fleet. But as you're collecting your data, is that data properly topologically structured? So, roads are typically broken down intersection to intersection, sewer, manhole to manhole, water, valve to valve, or other devices. In some cases, there's the change in the material, the change in the dimensions. If the data is not structured properly, you're not going to be able to do comparison analysis of, if we replace this road, what are the water mains, what's the underground utilities that will be affected by it? And so you collect the data from a tabular perspective, you validate it against your graphical. And whether you're using Google Map, whether you're using a proprietary piece of software, whether you're using Excel, that's not really the important part, is the data properly structured? One of the other key components in moving forward is also with climate change. More and more insurance companies are asking that municipalities start to take this into consideration. So things such the resilience to a 100-year storm. If we're going to redesign an asset, are we going to take the emission into thought when we're doing that? If we're going to decide whether we're going to keep a building or tear it down, are we putting into consideration the emergency readiness when trying to make those decisions? So this is where it gets kind of interesting. And the chart is skewed on purpose, right? What we have noticed is that, a lot of the treasurers and so on, they don't take into a lot of consideration the deterioration model. And that deterioration for a road, for water, sewer, bridges, fleet, inventory, facilities, it's different. And by just using a straight line depreciation to establish your level of service, you're not really doing any justice to maintaining those assets properly. So once you've collected the assets, it's about your life cycle events. And again, regardless of what tool you're using to do it, are you validating the process? Are you ensuring that, yeah, when it hits 65 PSI, we're going to do a thick overlay on that road? Are you able to share that information with the other department heads? And is there collaboration and agreement? Do we have an actual life cycle cost specific to our municipality, or are we just using some number that a consultant might provide for us? From an engineering perspective, can we validate what life we're going to gain or what the new PCI will be? And ultimately, are these steps in line with the local municipalities around you? When we talk about levels of service, risk always becomes a key component of it. And again, risk is measured with consequence of failure and probability of failure. But again, one of the challenges is to what degree and how detailed are you going to be in collecting the data? From a consequence of failure, these are some of the fundamental aspects that you should be including. The health and safety from an operational perspective, the environmental effect that it would have, what financial costs are you willing to accept, what are the legal regulations that we have to adhere to. From a probability of failure, again, what we've noticed is in most cases, it's just a straight line depreciation. If it's a 100-year pipe and it's 50 years, then it must be only 50% left good. But really, municipalities should take into consideration beyond the useful life, at the most basic, the condition rating of the asset, the network value, the priority value, the number of repairs, as well as what are the operational costs. At what point do we stop spending operation money and start talking about capital? So now that we've put together the risk of the consequence of failure and probability of failure, another key component really is assigning weight to each one of those criteria. And so as an example, the probability of a chiller failing is not as severe as the consequence. And so if we assign the same value to both the consequence and the probability, when we try then to analyze our position, it doesn't really give us the factors that are required. And so in some case, the probability of failure might outweigh the consequence of failure or vice versa, 7 to 3, 5 to 5, that really becomes an internal discussion. So the importance of all this is because you have so many different assets, you need to be able to normalize the data. You need to be able to make all the assets have that, 1 to 10 value or 1 to 5 or A, B, C, D, E. And you need to do that at the category level. So we want to compare our roads to our sewer, to our water, to our building. But if you do it properly, you also should be able to drill it down to the individual asset. So how do I compare a specific size water main to a ice resurfacer to a chiller? And so by structuring your data properly, you're able to collect that information and you're able to visualize it properly. And the visualization is the kind of thing that's going to help you to ensure that when it comes to whether it's an internal meeting, whether it's a meeting with counselors, whether it's a meeting with the public, you're able to share that information with them and it's consistent and you can validate that. So all of this comes together in the fact that, what Marmac has tried to do is to establish a community of best practices. There are a number of municipalities that have participated and that are sharing information with others. And if any of you are interested, feel free to reach out to me. Having said that, that takes care of the presentation portion of it, and I'll be happy to take any questions if there are any.
Thank you very much, John. While Dan's collecting the questions, I'll start by asking a question of you. You've been working with municipalities for a while. What are some of the concerns you hear from staff in terms of asset management? Because what I have heard is that often, budgets are tight and the tendency is to deal with the worst first, meaning, instead of looking at the life cycle of a road, go and fix the road with the potholes first and deal with that rather than the long term. And it often almost appears that the upper levels of government reward municipalities that haven't done a good job with asset management and give them more money to go fix problems. So I wanted to ask your thoughts on that.
Yeah, so it's kind of interesting, Salim, because we've worked with MFOA, RFA, OGRA, to a limited extent with MEA as well. And there's a couple of interesting things. I think that the first step is treasurers have taken the lead in preparing these asset management strategies. And although they do a good job from a finance perspective, they lack the details of understanding what the options are. Now that they're taking into consideration buildings and facilities, that's even a higher level because there's very limited knowledge of a chiller, a compressor, an ice resurfacer. And I'm going to answer your question because there is a lack of understanding. There's a lack of being able to defend the positions that we take. And so when we go to council and we say, here's what we want to do, and council starts to ask questions, most small to mid-sized municipalities struggle with sufficient resources and knowledge to be able to defend it, and that standardization to say, here's how our neighbors are doing. So the reality is that there's a lot of confusion. I think that the province and the feds are looking at ways to reduce how much money they're transferring, and any opportunity that they have to do that, they'll take that.
Okay, thank you, John. Dan, do we have questions from the floor?
I haven't seen any. Let me check one last time. No, there are no questions.
Okay.
Salim, I want to thank you very much for having given us the opportunity to present, and I wish that the rest of your conference goes as well as it did this morning.
Thank you so much, John. On behalf of the MEA, we thank you for coming here today to give us this talk about asset management. And on behalf of the MEA, we'll be sending you a digital gift certificate as a token of our appreciation. Thank you so much.
Thank you.
Okay, our next presenter this afternoon is going to talk about the state of the North American asphalt binder specifications. And the presenter today is Emma Wakefield. Emma has a materials engineering degree from Manchester University and a master's degree in civil and environmental engineering from the University of Waterloo. She has worked with Acorn Construction as the quality manager for design build projects, and with Miller Paving managing quality control, quality management systems, and the corporate research and asphalt mix design lab. In her current role with the Asphalt Institute, she conducts research, training, and provides technical guidance in asphalt quality for the Institute's Canadian membership and owner agencies. Welcome, Emma.
Hi.
Hi, Emma.
How are you doing? Thank you.
Very good, very good. Thank you. All right. Let's proceed with the presentation. You want to start sharing?
Yeah. Do you see my screen with full screen?
I do.
Great.
Yep, full screen. Thank you.
Thank you.
All the best.
Hi, everyone. So nice to be here. Thank you. My name is Emma Wakefield. I'm the Canadian Regional Engineer with the Asphalt Institute, and it's my pleasure to give you this presentation on a status update or the state of North American asphalt binder specifications. We try to do this annually, and we compile data by kind of meeting with all of the regional engineers within the Asphalt Institute who cover different territories within the US, and I cover Canada, and then we come up with this summary. By the end of the presentation, I will be requesting you to help me out, specifically from a municipality standpoint. We have this information for provincial and state DOTs, but it's really difficult to get the information for the municipality. So we have I've put together a survey that I will share with you at the end for getting similar information that I'm about to share here in terms of types of binders specifications used and mixed design specifications used, and sort of distresses experienced in your network to help me be a better regional engineer for you. So, right, so the outline is that I'm going to talk about the two Ashto asphalt binder specifications that we use, and any changes that have occurred to them, and who's using which specifications. And because our specifications are always changing as we learn more about the materials, we'll talk about what's next in terms of binder specifications. There are two Ashto asphalt binder specifications, Ashto M320 for the standard specification for performance graded asphalt binder, and Ashto M332, which is the standard specification for performance graded asphalt binder using the multiple stress creep recovery test. You may have heard of this. It's not a new test, but it's slowly being implemented in industry. And so we talk about who's using it, who's transitioning, and why we use it. The Asphalt Institute recommends that agencies adopt the massacre specification, that's the Ashto M332, because it represents a technical advancement over the original specification. As you learn, you improve, and you make changes, and you adapt. So this is a technical advancement over the original PG grading. So the reason is it helps to better characterize the high temperature performance related properties of the asphalt binder. And how that even came about is because of how much polymer modified asphalt binders are being used. That usage has grown tremendously over the past several years, because of the need to meet the demand for higher truck traffic loading on our asphalt pavements. The challenge is that the Ashto M320 specification for performance graded asphalt binder, the study that was done to come up with that specification only utilized neat, unmodified asphalt binders. So that's why it's difficult to characterize modified binders when you're using the PG system. Now, the photos that you see on the slide, they show trial projects that were used to kind of show what I'm talking about. So the top picture shows a pavement section that was paved with PG 67-22. Keep in mind, the same aggregates were used. It was same traffic conditions and environmental conditions. The only difference between these two trial sections is the asphalt binder type that was used. So 67-22 unmodified in the top one, and 64-22 polymer modified for the bottom section. Now, based on their PG grading, what we understand about PG grading, the PG 67-22 should be more resistant to rutting and compared to the PG 64-22. However, when we went into the field to do a field assessment, it showed that even with the same environmental conditions and the same traffic, 15 millimeters of rutting was measured in the 67-22 section, while in the 64-22 section, there was no rutting identified. So it's field trials like these that raise questions about how adequately the PG M320 is able to characterize polymer modified asphalt binders. And that's why the Institute recommends moving to the 332. So because it's important to show the data that supports this statement, here is where we're showing the comparison between the parameters that are used to characterize rutting. So in the massacre specification, that parameter that's related to rutting at high temperature is called the non-recoverable creep compliance, or the JNR. If you look at the graph, I'm going to explain what both of them are showing, but the parameter in the Ashto M320 specification that characterizes rutting is the G star over sine delta. So these two parameters are both characterizing rutting, but in the two different specifications. Now, what you're seeing in the graphs is a correlation between each of those parameters compared to a field assessment. And it's an accelerated field assessment that was done at the Federal Highway Authority's Accelerated Loading Facility, or ALF. What the ALF does is it simulates truck traffic with controlled loading and pavement temperatures, excuse me. And because of this, within a few months of running at this facility, you can simulate years of traffic, and you're able to collect data related to the distresses, and then you're able to compare the different pavement sections. So that's what was done here. And in the left graph, it shows the correlation between the G star over sine delta rutting parameter in the Ashto M320 and how it compared to the measurements from the ALF. And then on the right, it shows the same comparison, but it's using the JNR parameter from the massacre test to compare with rutting. And you can see based on the R squared value, and R squared is a correlation that shows how well the two are correlating, and an R squared closer to 1 is better. So R squared for G star over sine delta is 0.13 when you round up, and R squared for the JNR was 0.82. So that's very good correlation, and further shows why we encourage the use of the massacre specification. Now, there are some changes that have been made to both specifications through the Ashto updates. You would have received it probably end of July or early August. There's a criteria, the G star sine delta criteria in the specification is currently 5,000, and it's going to stay 5,000. However, there's been a series of challenges with the variability of testing, and also how that limit kind of eliminates well-performing binders. And you want to make sure that you're not eliminating well-performing binders due to testing variability. You want to eliminate them for the right reasons. And so through research, we've determined that binders that have a G star sine delta above 5,000 and up to 6,000 can still be considered acceptable as long as you look at the phase angle. This is information that is pertinent to testing labs to ensure that they are looking at the specification and not rejecting binders based on that parameter because it's updated, but also to let agencies know that suppliers also are aware of these changes in the Ashto specification, and they are going to be adhering to those going forward. So this is an awareness for agencies to know that the Ashto specification has changed. It's a small change, but it's impactful if you're not looking at making sure that you do look at the phase angle if the G star sine delta falls within 5,001 to 6,000 kPa. So with that, let's look at, I guess, a national snapshot of who's using which specification in the US and in Canada. We'll start with Canada. The specification for there are 3 provinces currently that are have fully implemented the Massacre M332 specification. So you can see highlighted in blue, Quebec, New Brunswick, and Nova Scotia. This change happened around 2019, but provinces like Quebec, they were testing massacre behind the scenes for about 10 years before going with that implementation. That's typical for agencies. You know, if they're progressive, they're doing testing for information purposes behind the scenes, and then once they have enough data, they can implement limits and or verify that it's applicable to their environment. So these 3 provinces have fully implemented massacre specification. Now, of the provinces that are not using massacre specification, some provinces still specify the massacre test when they're calling for polymer modified asphalt binders, because that's the whole purpose of the massacre test, is to better characterize those binders. So you can see highlighted British Columbia, Alberta, Saskatchewan, Manitoba, Ontario here, and PEI. In their specification, they have it in there to conduct the massacre recovery as a PG plus test. Some agencies do this while they're transitioning to the Ashto M332, just so that it's easier for industry to make that transition. It's not, you know, one clean kind of ripping off the Band-Aid effect. That's not necessarily the approach to go with when you're changing specifications related to infrastructure and asphalt binder. So they're using massacre test when they feel a need to, and we'll keep track to see if this map changes as we go ahead, to see if they are going to be fully implementing the massacre specification. In the US, currently there are 16 states, and this is changing all the time. So there may be one more state, since we did this back in November 2020. So we're due for another update. But when this was updated, 16 states had implemented the massacre specification, and you can see them highlighted in blue there. In the light blue states that are highlighted, that's similar or not to states who are kind of using the massacre specification, but not. Some of these states, they have the contractor opt in, or some of them will use it for polymer modified binders only. And so they're not fully there, but they're kind of getting there. And so we highlighted them in blue, light blue, so that you can see who's kind of thinking about it. So what's next? There are a lot of things that are next when it comes to the asphalt binder specifications, but a lot of them are still in research phase. Actually, they're always in research phase, because we're always collecting a lot of data. So what I'm going to share with you here is the delta TC parameter, because the delta TC parameter is one that we actually have a lot of information on, and we even have a state of the knowledge document produced by the Asphalt Institute Technical Advisory Committee. And so I can share that with you on if you wanted to get more information. So I'm going to talk about the delta TC parameter as one that some agencies are looking at. So what is delta TC? Delta TC is an asphalt durability parameter that was talked about by Mike Anderson and Phil Blankenship in a paper in 2011 at AAPT. This parameter can be determined by conducting tests that are typically done on binders in the PG grading system, if you do the full grading. So in a way, it's an attractive option, because some agencies don't want to have to add yet another test to their matrix if they don't have to. So if there's an opportunity to get more information by analyzing the data you're currently collecting in a different way, then that's advantageous. And that's kind of how delta TC is playing out. It provides insight into the asphalt binder's ability to kind of relax after it's been under a lot of stress. And this is very important when you're looking at non-load related distresses. So things like block cracking or raveling, as you see in the bottom middle picture, or age-related embrittlement. So as the asphalt pavement gets more and more oxidized, its ability to relax these stresses becomes more and more difficult. And so delta TC gives you an idea of how well that the binder you're using is able to relax those distresses. So I mentioned that it's calculated from the test that's already done in the PG grading, and that's from the BBR test. That's the low temperature test. The critical temperatures that are determined from the BBR test for stiffness and M value, when you subtract them, that's where you get the delta TC. And this is done through the Ashto R29. That's for doing the true grade for an asphalt binder. What can you learn from delta TC? Delta TC can tell you about, depending on what the value is. So the delta TC of an aged binder, it would be more negative than the delta TC of an unaged binder. So the delta TC of an unaged binder, you would be more comfortable to say that it wouldn't be more susceptible to the distresses that I mentioned. Whereas a very negative delta TC would tell you that this binder would be more susceptible to the block cracking, raveling, and kind of age embrittlement distresses associated with that binder. So it gives you a good idea if you're comparing the values. Comparing values, in Ontario, we conducted an interlaboratory study of 5 labs to test various parameters for asphalt binders that are used in Southern Ontario. And delta TC was one of the parameters that we calculated from the tests that were done. And here you're looking at delta TC values for 20-hour PAV aging and 40-hour PAV. So 20 hours PAV is the standard in the current testing for PG grading, but 40 hours is being discussed because we want to look at sort of the extended aging and also discussions about whether or not the 20-hour aging is severe enough. So we compared 20-hour and 40-hour PAV aging and calculated the delta TC values. This is giving producers and also agencies, where do we currently sit in terms of the delta TC value for the binders used in Ontario? And it is source specific, but you can see the range in the values for the different asphalt binders. You can also see the difference in 40-hour and 20-hour PAV, but interesting to note that the difference in 20 hours versus 40 hours is not the same for all of the binders. And so this is a very important chart to show also that when you're talking about delta TC, the condition or the aging is a very, very important thing to also include before we start looking at limits and what the delta TC value means. So be sure to know if you're looking at 20-hour or 40 hours. If you would like more information about delta TC, I mentioned we do have a technical document on this. It's on our website, free to download. It describes the current state of the knowledge of delta TC. It's not intended to persuade or discourage an agency from using it. It does describe sort of the key steps an agency should look at if you are interested in collecting delta TC data for your projects. And it also shows how other agencies have done the same. So there's a lot of good information in here. It's a 64-page document. It was published back in 2019, October 2019. And one of the great parts is the frequently asked questions section of this document. We break down all of the questions that we get typically on delta TC. And so you can start there. If you don't have time to read the whole document, you can literally start at the frequently asked questions section of this document and get a lot of good information and then come back and read the document later. Now, I know I gave an overview of the asphalt binder specification. It was intended to be kind of a broad national snapshot. If you want the specifics of the specifications, you can go to our website, the Asphalt Institute website. We have a specification database that we try to keep updated on an annual basis. And if you want to know, all of the different provinces and states, what they're using, you can go there and download them. If you see any errors in them, please let us know, because we are doing these on our own. So if you see any discrepancy in the specifications, just send me a note and I will update it for the Canadian ones. With that, I would like to thank you very much for your presentation. I did mention that I'm looking for your feedback in terms of helping us collect data for municipalities, and in terms of what specification you're using, what challenges you may be having, what mixed design specifications you're using. This really helps to tailor our research, our technical documents that we want to present, and also presentations that we need to share with industry, especially agencies who are just want to know more about how to get the best quality out of their asphalt roads. Thank you so much for the opportunity, and I will now welcome your questions.
Thank you for your presentation, Emma.
Thank you, Sally.
I'll wait for questions from the floor. I'll get this started. I just wanted to, not about your presentation, but I know that you are, working with Asphalt. So I had a question for you about the state of the industry in Ontario. Few years ago, we had, issues in the industry with the use of recycled engine oils and, the quality concerns around that. So I was wondering if you can comment on the state of the industry and if there are any challenges that the industry is currently facing.
Thank you, Salim. That's a very, very good question, and very appropriate and timely. We are still, as an industry, we're still talking about how to improve the durability of our asphalt pavements, especially as we start to incorporate recycled materials in our pavements, because we don't have much choice. If we want to maintain sustainable, we have to find the best way to reincorporate that material back into our roads. But what we've learned over the years is that the way we've been doing it in the past was not necessarily giving us the best performance. And we've seen that through premature cracking and just overall not getting the same longevity out of our asphalt pavements. But we've also learned that we've learned some of the reasons why that was. And so agencies are making changes to improve that. And some of those are making sure that you specify the right asphalt binder, ensuring that there's an adequate asphalt binder in the mix. But even beyond the mix design, we've learned about how to ensure that proper inspection is being done, and proper construction practices are being followed. So the challenge now is how do we fill in the gaps, knowing what we have to do now to improve quality? So you're going to hear a presentation later on performance testing. We've learned that is it gives us more information about the asphalt mix that we need to understand to see how to better predict field performance, because the parameters that we're using now, based on volumetrics, they can only tell us so much. So you're going to hear about changes that are being done there. For the Asphalt Institute, we're answering the question of inspection by offering courses to inspectors. What to look for when you're at the asphalt plant, what to look for when you're looking at a mixed design, test results, what to look for when you're on the construction site. Those things that also contribute to asphalt performance that we can't design for, the inspectors need to be able to identify those. So we have a paving inspector course that we have launched and making available to agencies and also quality control staff, so that they know what to look for from the supplier side, so that you and the inspector are talking about the same thing, you're on the same page. So though the challenges still exist, Salim, but I'm optimistic that we are learning and doing the right things to move forward to address the limitations that we had before when we were trying to incorporate the recycled materials.
Thank you. Thank you. Could you share that information on the paving inspector course with our executive director, so that we can pass on to the membership? Because I think people would be interested in knowing more and where they can find more information.
Absolutely.
Okay, unless there are questions from the floor, I have a second one. Dan?
Go ahead. I'm just verifying that our Q&A is working here. I've asked someone to send me a test question because I haven't seen a question come in. So go ahead, ask your question.
Okay. Emma, I've, I think, seen a presentation from you a couple of years ago. And I think at that time, you're talking about, warm asphalt and, encouraging, agencies to take on that. And now that, everybody is thinking about, reducing greenhouse gases, and we all know the benefits of warm asphalt because you don't need to heat it up that much. Do you have any idea on what the take-up has been in the industry?
Yes, actually, this year at the Canadian Technical Asphalt Association, I gave a presentation on warm mix, because over the last couple of years, it's been, what happened to warm mix? What happened to warm mix? We know the benefits of warm mix because they've been demonstrated benefits from the environmental side and from improving compaction, so that improves performance. But there has been a challenge because agencies don't know how to specify it so that it can be used properly. With more and more pressure to be green, warm mix asphalt is still one of the best ways really to meet those demands, and also taking advantage of all of the added benefits that come with warm mix. So warm mix is still a viable option for agencies and for producers and our industry in terms of making sure we reduce our greenhouse gases. In Ontario, MTO is working on a document right now to, I guess, work towards warm mix implementation for 100% of their mixes. In New Brunswick, they started producing 100% warm mix 2 years ago, and they're continuing to do that because they're seeing success in introducing it into their industry there. In Alberta, there's data being collected to ensure that the emissions can be quantified, because for them it's a matter of showing I guess it becomes political, right? But that doesn't mean it's a bad thing. It just means you need to show the data to support why you want to use warm mix. And one of those is for them to collect emissions data that shows the reduced emissions. And I can also share with this group an article that we've written in the Asphalt magazine on comparing warm mix asphalt with some of the changes that are currently being made right now to improve the durability of hot mix, such as increasing the asphalt binder. We have data that shows that warm mix is able to provide similar or better performance than increasing the asphalt binder content. And then you get all the other added benefits that come with using warm mix. So there are still great examples of warm mix living up to the original idea that it's environmentally friendly. But we, as an industry, we really need to work on how to specify it so that agencies are getting what they want, but also contractors and suppliers are able to produce it without too many limitations on them.
Okay. Thank you again, Emma. Dan, any questions for Emma?
We do have one. There's a lot of information, a lot of specification data that you presented, Emma, and one of our members is asking how you work with, for example, MTO to get this specified as part of Ontario provincial standards.
Every agency is different, and some agencies reach out more so than others. Ontario has a very extensive research program that they do, and so a lot of times we're in line in terms of doing the same kind of research and just waiting for everyone to have their data to share. So, for example, with Ontario, one of the challenges we had was with the recovered asphalt binder testing. And so we work with MTO to ensure that the data that they have to support what kind of the concerns that they have and why they were trying to implement the specification. And I worked with industry and with MTO to collect industry data. And once we shared it, I guess we mutually learned. MTO has now reduced or made changes to their specification, for example, on the ash content. Before testing a recovered asphalt binder, you have to ensure that there's a limit on the ash content because that can impact the results. That was part of the study that was done within the industry, which I led that with the OAPC and working together with Asphalt Institute Lab, and we were able to come to a change. So MTO has made that change, and we work with them when they want to work with us or when they want to share information that they have that we could either verify or give our opinions on. And then other agencies, they wait to see what other agencies are doing, and then they follow suit. So it really depends on what the agency has in terms of expertise. But I'm really available to all agencies depending on whether they have any challenges or if they don't have any challenges and they just want to share what's working for them.
Okay.
That's it for questions, Celine. Thank you, Emma.
Thank you. Thank you very much, Emma, for your presentation on behalf of the MEA. Again, thank you, and we'll be sending you a digital gift certificate as a token of our appreciation. Thank you so much.
Thank you. It was a pleasure.
All right. Okay, now it's 2:28. I'm going to suggest we take a 5-minute break. So 2:28, let's try and get back by 2:33. If that's okay with everybody, let's take a 5-minute bio break. All right, we'll see you soon. 5 minutes, please. Okay. So the next presentation is transitioning municipal infrastructure to a low carbon economy using Portland's limestone cement. Our presenter today is Tim Smith. Tim is a Senior Director, Built Environment, Transportation and Public Works for the Cement Association of Canada, responsible for providing technical expertise and promotional support to internal and external customers related to transportation infrastructure, cement, and concrete products. Tim was also the former Director of Transportation and Public Works for CAC, where he worked as a technical expert on concrete pavements, roller compacted concrete pavement, engineered soils, and brownfield remediation. Tim is a former pavement and remediation solutions manager for Lafarge Canada. Tim also worked with the New Brunswick Department of Transportation, Marine Atlantic, and Englobe. Tim is a member of several technical committees. Tim holds a BSc Engineering and a Master of Science Engineering in Transportation from the University of New Brunswick. Welcome, Tim.
Thanks, Liam. Much appreciated. I'm glad to be here. Only wish it could have been in person. So I'll share my screen here.
Me too.
I'll share my screen here now. Start from the beginning. There, can you see my screen?
Yes, I can.
Great. Okay, thank you.
Yeah.
So my topic today, I just wanted to start out by giving a bit of a background on concrete's pathway to carbon neutrality. I'll go over some of the things we're doing in our industry. I'll look at industry's role in reducing our carbon intensity for concrete. I'll look at designers' roles for reducing the carbon footprint. I'll actually go over a document that the Cement Association of Canada has produced to give people an understanding of what Portland limestone cement is. I'll review a number of the projects that have used it, and then I'll just show, give a URL to a website that's on specifically about greener cement, and it's about Portland limestone cement. So the first thing I think it's important to give a bit of a background on concrete's carbon life cycle. You have the raw materials that you need for your concrete and for your cement. You then have your cement manufacturing. You have your mixing of the concrete. You have the transportation of the concrete to the job site. You have the use phase of whatever product that you've done, whether building a bridge or a pavement. Then you have the end of life of your product. Now, 95% of concrete actually is being recycled at this time at the end of its useful life. Is either being used back in as a granular base or actually back into new concrete. The key thing I wanted to point out here, the carbon footprint of concrete is quite low, but the cement is 80 to 85% of the carbon footprint of concrete comes from cement, even though it's only 10 to 15% of the mix. So concrete actually is lower, but the cement does have a high CO2 footprint. So an example for 30 MPa concrete, you have 386 kgs per cubic meter is your carbon intensity. For this cement, it's around 309 to 328 of that carbon footprint is actually the cement itself. So why is that? It's because of the way we create the cement. We have limestone and clay. It's put in their kiln. The temperatures are around 1,500 to 2,000 degrees Celsius in these kilns. This actually has to heat up the materials to a very high degree. It actually drives off the CO2 in the limestone. So 60% of the emissions is actually due to the CO2 being driven off of the aggregates, the materials. 40% of it is through the combustion process of having the kiln at such a high temperature. The clinker is then collected. It's then for just general use cement. It's you have up to 5% limestone is ground back in with the clinker, along with gypsum to create what's called Portland cement. You then take the sand and coarse aggregates in the water and the cement, and that creates your concrete. So the big thing is that your CO2 is created through creating the clinker itself, and through the combustion process with you have either coal or natural gas is normally being used as your source of fuel. So what we've done in the concrete industry, and you'll see that there's been a lot of roadmaps to carbon neutrality have been put out in various industries. Canada is actually working on ours right now. We'll be releasing one early next year. But we've already started the process. Back in the 2000s, we started actually doing energy efficiency analysis on all of our plants and our sites to make sure that they were running at the most efficient way that they could to minimize the energy that's being used in the plants. The next stage is for us is to look at the low carbon cements. Now it's interesting here, we've been using low carbon Portland limestone cements for around 10 years or more in Canada, but they've been used since the 1990s, early 90s in Germany and England and several other places in Europe. So it's not a new technology. It's one that hasn't been used as much in Canada, but I'll show you lots of examples where it has been. We're also looking at low carbon fuels. I have a slide on that, but what we need in this case is we need regulations to change so that we can burn things such as tires that can't be reused, and plastics and biofuels. Then there's mineralization and carbon utilization is another area where we're spending a lot of time research on, and then carbon capture and storage. So I'll be going over these in a little bit more detail. But another point that I wanted to make as well is concrete will naturally start to carbonate because it wants to take back some of that CO2 that it released in the process of creating the clinker. So studies have shown that the uptake can be between 40 to 90% of the CO2 that was originally emitted during the creation of the cement. So we do know that carbonation is something very positive. So we need to take that into account when we're looking at our designs. So what's our industry's role? What can we do? The number one thing is the use of low carbon fuels. Instead of using the fossil fuels, we want to diversify our fuels that we're using for our kilns. So we look at construction and demolition waste as one area that we're using in our kilns. We also look at using non-recyclable plastics and non-recyclable tires. There's a lot of work being done now on biosolids so that we can again reduce the amount of reliance on fossil fuels. There's renewable natural gas that's being looked at as well, and hydrogen projects are being looked at. So we have a potential of really reducing that reliance on the fossil fuels by at least 30%. So if you just take an example of a 25% reduction by using the low carbon fuels, we can reduce the 30 MPa that I mentioned earlier from 386. We can reduce that by 30 kgs per cubic meter. So there's a substantial amount of savings can be used by burning different types of material in our kilns. Now, another important area is the carbon capture, utilization, and storage. And there's two main areas here that we look at. There's a carbon capture at the cement plants, where we can capture that the CO2 that's being emitted, and that can either be stored down in the ground, or it actually can be utilized to create other products. Such as Blue Planet, they actually have a system where they take the CO2 and they can produce aggregates out of that. So there's a lot of research out there right now, and there's some forms such as Slidia that uses less energy to produce the cementitious material as well. And then you get carbon cure, another technology, which actually injects carbon into the concrete to a way of utilizing the CO2. So there's a lot of ways there. The carbon utilization in concrete and the carbon capture are areas that we're spending a lot of time and effort in researching these areas. What the easiest low hanging fruit is actually clinker substitution. And there's two main ways of doing that right now. One is to use the Portland limestone cements. As I mentioned earlier, in Europe, they're actually using this commonly, and they're at 20 to 30% substitution in the limestone, where we're at only up to 15%. So they've been utilizing this technology for some time, and we're just starting to catch up to them on that. The other is actually increasing the use of fly ash, slag, and other supplementary cementing materials. So what is Portland limestone cement then? Looks like the same picture that we showed just a minute ago. You have your raw materials go in your kiln, you produce the clinker, you still have the process emissions and the combustion emissions that occur. But what we do is when we collect the clinker, Instead of the gypsum and limestone, the limestone being at up to 5% for a general use cement, we go up to 15% in the Portland limestone cement. So that's an automatic around 10% reduction in amount of CO2 attached to the cement. So it's kind of a green for free. There's no additional cost to doing it. What they do is they still have the grinding process. And when they're doing this, they actually grind the blane of the Portland limestone cement is a little bit finer than the conventional GU cement. And that actually gives you some advantages from the strength side and the setting time. And then again, you just take the Portland limestone cement, you mix it with the fine and coarse aggregates, water, any admixtures to create your concrete. So it's the same process to create the clinker. It's the difference to create the cement itself. So Portland limestone cement, I'll be showing some slides here shortly about the same durability and performance. It's approved through the CSA codes, CSA 3000. You can go to the compendium. So if we could take all the cement that's being used in Canada and convert it over right to GUL instead of GU cement, we'd have 1 million tons of GHG saved each year at no cost. It's just a straight replacement of the GU cement with GUL cement. There's a higher limestone capabilities or amounts are available as they use in Europe. But right now we're just using the up to 15% that's been approved in the CSA standards. Benefits also can be increased by utilizing supplementary cementing materials. So if you use the Portland limestone cement and then use up to 30% supplementary cementing materials, you can see that the example I said you had 30 MPa concrete would have 386 kgs per cubic meter is the attached CO2. But if you use the Portland limestone cement with 30% SCMs, you're down to 270. So that's a tremendous reduction available if you start to utilize the Portland limestone cement with the supplementary cementing materials. So supplementary cementing materials have been used for a long time in Canada. We have guidelines in CSA A3001 that tells us how we should be using it. There's blends of one supplementary cementing material with cement. There's some with 2 supplementary cementing materials, and there's actually cases where there's 3 different supplementary cementing materials blended with the concrete. So it's a very well utilized process. And the benefit of using supplementary cementing materials is that you can get increased performance. If you're looking at fly ash, you'll get increased strength gain over time. Your Coulomb rating will be lower, so you'll have a denser concrete. Same thing with slag. You'll have a more consistent performance because, again, you're having to increase strength and you decrease your Coulomb rating as well. So your strength and durability are there. The silica fume actually is 1/100th the size of a cement particle, so it actually makes it even denser and stronger concrete. But there is a cost to silica fume compared to that of slag and a fly ash. Then there's also natural pozzolans, that's such as metakaolin. There's other ones that we're looking at, and we're also looking at the harvested fly ash to ensure that we have a good supply of fly ash available for our concretes in the future. So what does this do then if we start accumulating all these things? So if we use the low carbon binders, so if we use the Portland limestone cement with the supplementary cementing materials, we can get a very large reduction in the CO2 attached to that concrete. So if we start looking at carbon storage and capture as well, it decreases it even more. If we start looking at other technologies such as creating the aggregates, we can see that over time we're going to decrease the amount of CO2 attached to the concrete. And as I mentioned earlier, we have a goal in 2050 to be carbon neutral. If we can have all these technologies of carbon storage, carbon capture, and all these technologies which allow you to, such as carbon cure, use it back into the concrete itself or create concrete aggregates, we believe that we will have a very carbon neutral product. And remember too, we have carbonation that's occurring on the concrete itself. So what is the designer's roles then? As a designer, you have to decide and communicate what carbon reduction goals you're going to have. You need to investigate the quality of the concrete that you're purchasing. We have in Ontario, we have the Concrete Ontario that provides high quality concrete, which the facilities are inspected. So you have a situation where you are provided a very good quality concrete. They can give you the strength that you want and optimize your mix design by you tell them that you want a class C2 exposure, 32 MPa. They'll be able to provide you that with the right amount of supplementary cement and materials in the mix to optimize the mix designs. And if you specify certain carbon reductions, they can work towards that goal as well. You can focus the performance rather than you want to have performance specifications rather than prescriptive, because if you allow the performance ones, it allows them better ability to optimize their mix designs. They can use the Portland limestone cement, they can use supplementary cement and materials, and you also want to consider the efficiency of designs. If you only need a 32 MPa concrete for a sidewalk or curb and gutter, because that's what CSA 23.1 says, you don't have to provide a 35 MPa, because if you provide a 35 MPa, you're actually increasing the CO2 footprint of that concrete, and you don't really need that strength. So follow the CSA standards on what's required, and that'll help you optimize your mix design and minimize that CO2 footprint. And you can also use you'll also reduce your CO2 footprint by allowing the use of these supplementary cement and materials and the Portland limestone cement. A good example of this is actually California, where they've actually specified low carbon concrete codes for projects. The top line is the National Ready Mix Concrete Association, the average values that they'd have for their global warming potential. And what California did is they specified the levels that they want. So to do these, they have to use the Portland limestone cement, and they have to use supplementary cement and materials to provide you with these lower carbon concretes. The Ministry of Transportation of Ontario is actually in their OPSS 1350 specification has actually specified global GHG reduction, a minimum of 10%. And they say you can get this through either use of Portland limestone cement or use of supplementary cement and materials or the limestone filler. Now they have actually allow Portland limestone cement in their specifications, and also they have the designated source materials list is Permeability allows the Portland limestone cement. So we also have the EPDs that are being looked at now by many architects and engineers to see what the global warming potential is. And you can see that if you use a GU cement versus a GUL, there's a difference of 10% in those numbers. So what the Concrete Ontario is doing, and the Canadian Ready Mix Association is actually doing, is they're redoing their EPDs at this time, and they're going to do them instead of on the national basis. They're going to be looking at them from a provincial basis. So this will allow our engineers and architects to understand what the attached global warming potential is for the various mix designs that you choose to do for your project. So just to go over the research then that has been done, we put together a technical summary document. The Cement Association of Canada, along with our members, and actually Doug Hooton and Mike Thomas, the two researchers that are well known in the world for their work on Portland limestone cement, they were involved in developing this document too. So what we did is we tried to explain what Portland limestone is, how is it manufactured, give a bit of history on the Portland limestone cement. We went in to look at the testing and the performance, which I'll show you some of the results of that. We also looked at what other jurisdictions are doing. There's a carbon reduction potential information in there, and there's key contacts and summaries. There's a list of project examples as well. And I can provide this document to MEA if you'd like to get a copy of it, or to any individuals that would like a copy. So what it does is it looks at different components of the performance. We look at the strength here. You can see that the Portland limestone cement and the Portland cement have a very similar compressive strengths when they were done at the 28 days for 40 and 56 for different water cement ratios. You see that the strengths are very similar. When we look at the strengths again, and again, this is work that was done by Thomas and Hooton. back in 2010, you'll see that there's very good correlation between the strengths of the two products. The PLC provides an equally performing concrete pavement, concrete, I should say. If you look at freeze-thaw durability, the ASTM C66 test, you'll see that there's very little difference in the performance of the two cements. And if you look at the scaling resistance, there's a line here that's drawn. It's 1,000 because the ASTM C672 does not specify what is considered good scaling resistance, but some jurisdictions do in North America. And the value that they use is 1,000 Gs per meter squared. And you'll see that in both cases, both cements are providing a much lower value than the 1,000. So there's no issue on the scaling side with either product. If we want to look at rapid Corallide permeability, that's the density, the ability for the chloride to penetrate into the concrete itself. You'll see that both the Portland limestone cement and the Portland cement are performing very well, very close to each other, basically within the standard deviation of the tests that were done. If we want to look at expansion, same thing. The expansion results are very good. They're all below the limit that's required. So we see here that the limits are very low. The limits are very low in this area as well. And same thing if we're doing the accelerated motor bar test or the prism test, the results are very similar. The two cements perform very well when it comes to expansion limits. And one thing that you will notice for the high early strength, you're going to get a higher early strength when you're utilizing the Portland limestone cement compared to Portland cement because it is a finer blane. It's ground finer, so it will react quicker. So you'll get that earlier strength gain than you do in a conventional Portland cement. Yeah, I won't go over these details. Is just in the document itself too. We have some visual rating information on sulfate exposure, and it gives you information on GU and different levels of Portland limestone cement, 9% and 15%, and HS cement as well, so that you can see and can compare the information. So again, this information is all available in this technical summary document that we prepared on the Portland limestone cement. So I thought it would be best to go through and give you some examples of some projects. So here is one of the very first ones in 2010 was on the Highway 401 here in Ontario. It was an off-ramp. So it was 450 cubic meters placed. It's performed very well. There was no issues in its placement. We see the Bayshore Shopping Mall did very well. There's 64,000 cubic meters over a 5-year period in the expansion of the parking garage. So there is a long history of the use of Portland limestone cement. There's the Pan Am Soccer Stadium that placed 11,000 cubic meters of it. And you'll see in these cases, there's a lot of times they'll actually include the supplementary cementing materials in the mixes as well. Other ones, Milton Verdon, Velodrome, 13,500. You get the YMCA building in Brantford, another 7,500 cubic meters. You see this time they use 25% slag in the mix as well, along with the GUL. So again, reducing that carbon footprint for that project. Highway overpass, they've even used Portland limestone cement for doing patching on overpasses. So this is done back in 2017. So it's very versatile. It's interchangeable. Portland cement and Portland limestone cement, it's just a matter of changing one in the spec for the other. There's no issue with changing one to the other. National Holocaust Monument, another example. And here you see that they use 20 to 60% slag in the mix. So again, we're trying to show that there's a lot of jobs out there that have used it. I put the times that they've been used in each one, the dates that it's been used, and the quantities, and a little bit of information in each project. So I can go on and identify that, but it'll be in the presentation that you see, that you'll be getting a copy of. So there's been a number of projects all across Ontario where this has been that's been used. The Google building in Kitchener used 17,000 cubic meters. So if you want to find out more, Portland Limestone Cement, greencement.com is the new website that was put up by the Portland Cement Association. And there's information on the Canadian projects in that as well. So you can go to that. And I just put a couple of slides of information that you may be interested in the future. So I've put 2 slides on that for you to look at later. So there's my presentation. So if there's any questions, I'll try to answer them. And thank you very much for allowing me the time to do this presentation.
Thank you, Tim, for the presentation. Very informative. Tim, question for you. So it seems like a good idea. It seems like a win-win for everybody.
Yes.
You know, when there is a product that, you know, provides all the benefits and it is cheap, people will use it. So how come we aren't getting proposals from contractors to substitute this one? Is it more expensive?
No, it says, well, I'm not a cement supplier, so I can't tell you the prices. But my understanding is the price of Portland limestone cement and Portland cement is the same. It's not cheaper, but it's not more expensive. It's just a matter of substituting one for one.
Oh, is it 1 for 1? So I was asking, do you have to put more cement to get the same strength?
No, all the tests, you saw the strength test results there. It's a 1-to-1 changing GU, put in the GUL for it. It's a 1-to-1. In fact, the Winnipeg is coming out with their new specification, and they're allowing the Portland limestone cement as well. And it's a 1-to-1 replacement. They don't require additional cement for the GUL. There was one job that was done in one jurisdiction where they actually thought that they needed more, so they put more in, and they wondered why instead of getting the 32 MPa, they were getting 38 MPa. Well, it was because they upped the amount of cement content for the GUL project, and it proved that there is no need to increase the amount of cement because it does provide you with the same strength as a general use cement does.
Okay, and one thing I didn't get from your presentation, Tim, is that, so is it that the same, so a company with a manufacturing plant producing cement, Portland cement,
Yes.
just has to do some modifications to add limestone, and you
No,
get product?
they already do. When you saw the let me see if I can go back to that real quickly. Here, oops, where to go? There. Okay, so the production of the clinker is exactly the same process. The raw materials go in, they're heated at a very high temperature to produce the clinker. The difference is in general use cement, this you take the clinker and you grind up to 5% limestone with the gypsum to create the Portland cement. What you do with general use Portland limestone cement is you grind up to 15%. So basically, because they can't go over 15%, it's going to be around 12 and a half to 13, somewhere in that range. Where in the normal GU cement, they're at around 2 to 2.5, so that they don't go over 5%. So basically, you're putting in 10% more limestone, which reduces your CO2 output by 10%. So because this goes up from only up to 5 to up to 15%. So that's the difference. So there's no difference in the, I don't know if you can see my arrow, there's no difference in the process here. The clinker requires 60% of the process emissions is the CO2 being driven off, and 40% is the combustion. So the issue becomes how much limestone is being underground with the clinker. So in GU, it's only 5%. In GUL, it's actually up to 15%.
Okay.
So there's no difference. It's underground to a finer blane as well. So it is a little bit more reactive. So it'll have a higher early strength because it's finer. So it'll react quicker. But the ultimate strength will be the same between the two.
Okay, so I guess what you're suggesting is that if more people start specifying that we need you to use this, then the industry will follow. Because it appears that there's no difference.
Yes, what we would do, what we hope is that the only thing that we'll be making in the future is Portland limestone cement, because our industry and all industries have to reduce their CO2 footprint. This is the easiest low-hanging fruit, is to change over to a Portland limestone cement so that you get an automatic approximately 10% reduction in your CO2 footprint. So it's and you for the same performance. One of our members say it's equal performance and green for free, because you basically have a concrete that will perform as well, but you have less CO2 attached to that because you're intergrinding up to 15% instead of up to 5% limestone.
And well, if you're saying if it's the same price, then even better.
Yes, and I say I can't talk about pricing because I'm not a cement person. I work for the Cement Association of Canada, but I don't work for one of my member companies. But that is the two products are identical when it comes to performance.
Okay, thank you.
Welcome.
And any question from the floor?
Yes, we do, Salim. It's a very general question from a member of the audience. Tim, would you have an estimate of the amount that cement production contributes to CO2 emissions worldwide? For example, the airline industry states it contributes about 10% of all CO2 emissions. Are you able to answer that?
Yes, actually, my understanding for Canada itself, because Canada would have less cement plants than other places, we're at 1.5% is my understanding. Worldwide, it's somewhere between 5% and 8%. It all depends. China has actually built a lot of new cement plants. So some of the places like that would have a much higher footprint when it comes to their own country. But globally, I think it's around 5, somewhere between 5 and 8%. But my understanding in Canada is only 1.5%.
Okay, that's it for questions, Celine. Thank you, Tim.
Thank you very much. Thank you, everybody. Appreciate the time.
Thank you on behalf of the MEA, and Tim again will be sending you a digital gift certificate as a token of our appreciation. Thank you.
That wasn't necessary, but thank you very much. Just a privilege to come on and be able to present. And I look forward to next year. Hopefully we'll be in person.
I hope so too.
All right,
thanks a lot.
Bye now.
I think there's a red button that says stop share.
Get out of the presentation itself to.
All right. Okay, thank you, Tim. Our next presentation is on review of the Federal Highway Administration publication on performance testing for hot mix asphalt quality assurance. And our presenter today is Mike Aurelio. Mike Aurelio is a senior quality control and product development coordinator with Yellow Line Asphalt Products. He completed his Bachelor of Science in Chemistry from the University of Toronto in 2012 and his Master of Applied Science in Civil Engineering from the University of Waterloo in 2020. Mike takes part in several provincial and national technical groups and industry associations. He also currently serves as the research associate at the University of Waterloo. Welcome, Mike.
Thank you. Thank you for that introduction. I realize it's actually probably a little bit out of date now, but and whatever picture I sent in is probably out of date too. So
we can see your presentation, so I'll get off.
Perfect. Thank you. So hi, everyone. It's a pleasure for me to be here. And I wanted to talk to you today about some of New Jersey's experience with performance testing. And you might be wondering why I wanted to do this. Partially because I reviewed this document as a member of the Ontario Asphalt Expert Task Group. And it's something that I shared with the group and presented, so I had a little bit of a base for it. But also, it's a document I keep falling back to when we talk about when we try to talk about performance testing. I think New Jersey's gone through something very similar to what Ontario's going through right now. So there's a lot of lessons that we can learn from them, and I wanted to share some of that information with everyone. So New Jersey's experience, like I said, it's similar to what we're going through or have been going through. They had a lot of longitudinal cracking as their primary form of distress. They were having a lot of performance issues. One of their first course of actions was to lower the number of gyrations. And this is something the MTO is currently working on or experimenting with, is finding a way to get an extra or an increase in the asphalt cement content of a mix. The MTO is also looking into, and I think done a few trials using the regression method this year, which is similar, has a similar goal in mind. New Jersey went through the same thing with lowering gyrations, and they offset their concerns by increasing their use of polymers. New Jersey also has a bit of an issue with RAP. I heard this, I remember reading this a little while ago, but because of their kind of environmental constraints, they aren't able to change the heights of their pavement. So they have to constantly mill out what's there and pave on the surface and repave on that. So they have a large stockpile of RAP. So because of this, there was some pressure from their contractors to increase RAP usage. And part of their desire to implement performance testing was to find a way to increase their RAP usage, but do it in a way that doesn't impact performance. So I'll talk about a couple of the general concepts first behind their system, and then go through a little bit of how they do it. They've learned from and borrowed from Texas. Specifically Fujitsu, Texas, at the Texas A&M Transportation Institute. And they've done a lot of work on performance testing and trying to move to a performance-based system. And in that system, the asphalt cement content is no longer a function of the air voids, it's now a function of the performance. So you perform a cracking test and a rutting test. And in some cases, you can prefer one or the other, but for this example, you perform both tests. You test the mix at 3 different asphalt cement contents, and you can see that from this graph that the rutting performance and cracking performance obviously change with the asphalt cement content. So what they find is that there's an acceptable range based on performance for the asphalt cement content. Then they ensure that the air voids are correct for that mix. These tests require obviously some correlation with field performance in order to have a relevance in the lab. But once you have that correlation, you can start to evaluate mixes based on their anticipated performance, and you can start to design things that way. So New Jersey has a 4-step process. You have volumetric design, mixture performance testing, then they produce a test strip, which then has its performance tested, and then they evaluate the mix performance during paving of the job. Okay, and you can see that the tests that they use here, I've listed them. I'm not going to get too bogged down in the details of that, because I think it's more relevant to have an overview of kind of how a system should work rather than all the intimate details, because those details will change depending on your climate, right? Specific like test temperature. I know we're already evaluating different tests than are listed here in Ontario, those types of things, but the overall system is still applicable. And you can see that they use the Texas overlay tester, and that's because of all the stuff that they learned from the work that was done in Texas. So the process is pretty simple. First step is to complete your volumetric design. Contractor performs that. It's verified by the DOT, similar to the way we do it here. Once that's completed, the mix is then submitted to a DOT-approved laboratory, so a consulting lab, where the mixture is tested for performance. Okay, and and the number of tests performed will depend on obviously the contract and the contract requirements. If the mix is successful, you pass all the specifications, or you meet all the specifications, you move on to a test strip. So the DOT and the contractor pick a location. They produce at the plant and pave a small test strip, and the loose mix from that project is collected and sent to the lab for testing. And then you verify the performance of that mix before you go ahead with paving the project. All right. If that test, once that test section is successful, then that's when you can move on. And they do continually sample loose mix during the duration of the project, and they test that as well for performance. The requirements you'll see when I'm going to be talking about a few different specialty mixes. So the requirements that were included in this document may have changed since then, but they also depend on the specialty mix, because some of these are produced in larger or smaller quantities. So speaking about those specialty mixes, there's 5 that are included in this report. You got your high performance thin overlays, your binder rich intermediate course, bridge deck waterproofing surface course, bottom rich base course, and the high wrap mix. And these mixes were all developed around the database they developed of performance criteria. So for several years they collected a large number of test results from various mixes, correlated that with field performance, and then found a way to select specification limits based on that data. So they used all that information to help develop these specialty mixes where performance was the priority. And I'm going to talk about 3 of those mixes just to give you some examples and talk about a little bit about how some of the lessons from these mixes can be applied here. So the high performance thin overlay, you'll know, and at the end I'll kind of wrap it up, but you'll start to notice there's a little bit of a trend in some of these. The high performance thin overlay it's a fine graded mix. It's got a 9.5 millimeter nominal maximum aggregate size. I'm not a mix guy, so I got it backwards. They use polymer modified asphalt. They don't use any recycled material. No natural sand either. In this specific trial they did, they only had a running requirement. I've looked, and since then their specifications now include a cracking requirement, but at the time it only had the running requirement. And this is still I think something we can learn from, because I think something that kind of goes unspoken is that with performance testing we're trying to ensure that we're designing the mix for the application we're going to use. So in this case, they were concerned. They understood that the design of the mix would be adequate for cracking resistance, but their concern was ensuring that it had adequate running resistance, because this is a mix that was designed with, I think it was something like it was either 6 or 7% AC content. So it's a very, very rich mix. They wanted to ensure that it wasn't going to rut, but they knew that because of the design, because of the extra polymer, that it would meet the cracking requirements. And this is something that we can kind of apply to our own knowledge, or our own application of performance testing. Places like France, for example, have varying degrees of testing. So certain projects they assume again that the cracking resistance is sufficient, and they only test for running. And then as you increase the traffic and kind of the size of the road and the importance of the job, they then crank up their mix requirements. So they paved this, they put this overlay on Interstate 287. This specific job was their primary issue was top-down cracking. It was a 1 inch, 25 millimeter thick lift, and according to the report, it's performing very well. You can see on the right-hand side sort of how their surface distress index changed after paving, and even 3.5, 4 years after the job, the pavement was still performing very well. And this has obviously then been used to develop some of their cracking criteria moving forward for this type of lift. Bridge deck waterproofing surface course. New Jersey has old infrastructure, and they were interested in developing a mix that would be compactable on a bridge surface with static rolling compaction. They can't use a vibratory compactor because of the age of some of their bridges. So they produced this mix. It's a 9.5 millimeter nominal maximum aggregate size, 7% AC content. They suggest that it's polymer modified or modified with a thermoplastic. Usually polymer modified refers specifically to SBS, which is what we use primarily in Ontario. And this mix specifically had a running and a cracking requirement. I believe they used the 4-point bending beam test on it, and which is a little bit more rigorous. They put this surface course on a bridge deck. It was a temporary bridge deck, Acro Bridge on Route 80. In this project specifically, the mix was pre-approved because it already exceeded the minimum requirements, which I think is something else that we can kind of draw from where I think there's concerns with what the cost associated with performance testing, but there will be situations where once we sort of get into it and we have an understanding of how it works, we can draw from previous examples, and we won't necessarily need to go through the entire process with every single project and every single mix. The reason they developed this mix though was because the original pavement they were using was being torn out every 6 weeks. Again, according to the report, the appearance of the pavement didn't change over its lifespan, and they considered it to have very, very good performance over about 1.5 years. So this brings me to the high RAP mixes, and in Ontario, I know we have some municipalities that limit RAP usage, and some I know have even eliminated it entirely in certain courses. But rather than work on sort of a maximum, New Jersey uses a minimum RAP requirement because they're, like I said, they have a massive stockpile and they're trying to get rid of as much as they can. So their service courses contain, their service courses contain a minimum of 20%, and their base courses contain a minimum of 30%. Through their research into their database, and then sort of comparing RAP mixes to virgin mixes, they found that they needed to increase their VMA specification by 1% for these mixes. Right? They also control the air voids a little bit more tightly. And again, the specifications are based on virgin mixes, so you can actually see at the bottom of the screen what the numbers are. And like I said, this comes from the virgin mix database, and their basic premise was we take a virgin mix that we know performs well, we perform these tests on it, we get these numbers. If I want to include RAP, that mix has to have the same numbers or better. All right, and that's the easiest way to do it, is to kind of just start with your virgin mixes and then slowly incorporate the RAP until you make the necessary adjustments until you reach the same level of performance on the tests you've chosen. So they performed a trial in 2012 on Interstate 295. You can see the final mix had 25% in the surface, 35% in the intermediate course. Binder selection was left to whatever was deemed appropriate for performance. So they didn't have any hard or fast rules on at what percentage you change the binder grade, for example. Because of the again, higher asphalt cement content, you can see the surface was at 6%. The intermediate course was at 5.8%. They had no issues with the compaction. They measured the roughness, measured the density, and they were able to confirm this after their analysis. Basically, it compacted and paved as well as a virgin mix. All right, and you can see here, if I go back to the binder selection, the surface course was at 25%. New Jersey's typical binder grade for a highway like this would be a 70-22. So even at 25%, they didn't bump they didn't soften the AC the way I think we would have automatically done here. Part of the way they accommodated for the wrap was that 1% VMA increase and the extra AC content. Okay. You can see in the intermediate course where they went to 35%, they did in fact drop the binder grade. Another thing I want to point out is at the bottom of that table where they talk about the fractionated wrap portion used. I think this is something that we need to do a little bit better in Ontario. And if you attended CTA last week, this was actually brought up in a little bit more detail in the CUPCA contractors workshop. And you can see that he's got this fine wrap and coarse wrap. And they do a little bit better job of fractionating the wrap and controlling the stockpiles. And that way they have better control over what's going into the mix. Fine wrap and coarse wrap behave differently. They contribute their asphalt cement differently because of their particle sizes. The diffusion will occur at different rates. So it actually does so it can impact the quality of the pavement at the end of the day if you're using if you're changing your wrap fraction size, for example. Okay, and here's just a quick picture of the pavements. They placed the high wrap mix directly next to a pavement using warm mix with 15% wrap. And you can see that they look pretty similar. I think as of writing the report, and I think even until today, they haven't had any major performance issues. Their high wrap specification is something they use quite frequently to help increase their wrap usage, right? This particular job, while they were paving it, they sampled every, I think it was every 3,500 tons. So every 3,500 tons, they grab a sample of this mix, perform their testing on it in order to verify that the mix performance wasn't changing as they produce the mix. So there's a few lessons I think that they learned early on while they were doing some of these specialty mixes. These mixes were kind of designed as experiments to make sure that what they were learning from their evaluation of virgin mixes was and could be applied properly to future pavements. So the first thing is they learned that their wrap mixes were under asphalted by about 0.6% on average. I think Louisiana did something similar, and I think they found it was 0.7%. So part of the problem with their mixes when they had their wrap mixes was they weren't getting enough asphalt cement content. All three of these mixes, sorry, technically it's 4 mixes, but 3 of the 4 mixes, the high performance thin overlay, bridge deck course, and the surface course of the high wrap mix were all 9.5 millimeter nominal maximum aggregate size. So they tended to move towards finer graded mixes, partially to move towards higher asphalt cement content. Right. The other nice benefit of using a finer mix is that it's less porous and it's going to reduce the rate of oxidation. Right. They decided that they needed to change their VMA specification for their high wrap mixes. Right. This is something that could be explored or researched further. And in our own case, it will depend on local materials. And then their database of mixes was obviously instrumental in helping them develop specifications. So something like a database would be very, very helpful in helping to understand where your specifications should lie. And then finally, they use a lot simpler simpler binder testing than we do. I believe they use Ashto M332, so just the masker specification, and they leave the selection of the binder let's phrase it this way. They determine the binder selection based on the performance of the mix. So they prioritize the mix performance. Okay, I'm a little bit over, but I will say thank you for having me, and I'll take any questions. And I will reiterate, this is based on somebody else's work, but I wanted to make sure that everyone had, it was shared, and I thought this was a very good audience to share this information with. So thank you.
Thank you, Mike. I'll start the questions.
Yep.
Mike, you talked about New Jersey, and I'm thinking that this is their DOT. So, usually, I would compare them similar to MTO, where they have big projects with a lot of asphalt that you can spend time, doing the testing and, test strips and things like that. A lot of our members, work for smaller municipalities where, the job, by the time you start and finish, it's like 2-3 days and we're done.
Yeah.
What recommendations would you have in that case? We usually take our cue from MTO on what is successful and not, what is working and what is not working, because they have bigger jobs to do all the trials they can do.
Yeah. So I think, New Jersey is because this is DOT work. You're right. It is very comparable to what the MTO would end up doing. I think personally, I think that France, it might in this case would be a good secondary example. So they have a tiered system where they don't perform all the testing on all of their samples. So part of the way it works is they do make some assumptions. So where they're working on where they're only using a running test, they're making some assumptions that the cracking performance will be sufficient. If you're concerned in the opposite direction, you can, like if you're trying to design a mix that's specifically for intersection or a very heavily trafficked area, you might be primarily concerned with rutting resistance. So you might only test the rutting. Did I say right? I think I said that. I think that was actually the same example twice. But there are situations where you can tune what you need based on the information and the pavement that you're trying to produce.
Okay. Thank you. Dan, any questions from the floor?
No, I don't see any have come in yet.
Okay. Maybe another question for Mike. In terms, I see, I note that you work for Yellow Line, and I wanted to ask you about supply chain. And, AC comes from the US or is it local?
We bring ours in either from Western Canada or from the US.
Any supply chain problems with the pandemic?
I kept hearing that there would be, and then it never materialized. So I think as far as I can tell on the asphalt cement side specifically, nothing. I know that a lot of major polymer producers are based in Asia, and with all the issues with transporting by barge and the container and all those container issues, that they're having some supply issues.
Okay. All right, last chance, Dan.
No other questions, Salim.
Okay. Mike, on behalf of the MEA, thank you for your presentation. And we'll be sending you a digital gift certificate as a token of our appreciation. Thank you so much.
Well, thank you for having me.
Right, thank you. So our last presentation for this afternoon session is updates on Ontario Provincial Standards 101 training. And the presenter is Arup Mukherjee. Just give Arup time to get on. Hey, Arup. So Arup is a professional engineer with 34 years of experience in the municipal engineering sector. He graduated from the University of Waterloo in 1987. He has worked for several local and regional municipalities such as Toronto, Markham, York Region, and Bradford, West Gwillimbury. He retired in 2020 from the counties of Leeds and Grenville in Eastern Ontario as the Director of Public Works. Arup continues to be active in the field by teaching workshops and is a part-time professor at George Brown College. Welcome, Arup.
Good to see you, Salim. Hopefully see you in a few days in person. So, yeah, and a number of other colleagues that are on here today. So thank you for that introduction. And I'm just going to get started here, being the last presentation of the day. We're going to just go into our presentation here. So first of all, I want to thank Municipal Engineers Association for providing this opportunity to be a part of this training and this workshop. I'm going to talk to you about the OPS 101, we call it, training workshop, whatever you want to call it, that I've been privileged to deliver on behalf of Municipal Engineers Association. So it's been a really fun ride. And just on a personal note, this workshop has helped me transition sort of into the teaching opportunity at George Brown College. So, which has always kind of been something I've wanted to do from a mentorship point of view. So it's been a lot of fun. So this is, we've been doing this course now for, let's see, just for three sessions now. So what is OPS? I think we have a very knowledgeable and informed audience out there, so I don't really have to sort of like we do in the training session, go through it in too much detail with you, but it's surprising. I think that there's still some advantage for everyone to kind of get this little bit of background. First of all, since many of you may or may not have a lot of interaction with the MTO, you should know that the OPS is jointly, there's two stakeholders, both the Municipal Engineers Association and the Ministry of Transportation look after these standards on behalf of the province of Ontario. It's been around a long time. Something I didn't know when I started getting into this, how long it's been around. So, it has a fair bit of pedigree, right? And a fair bit of history behind the Ontario Provincial Standards, which are, as you know, made up of documents and specs that are used for all kinds of public works or construction that we do out there. They are really standard, so they're province-wide. And, one of the benefits of that is that you are having both consultants who often do a lot of work with municipalities preparing contracts, contractors who are bidding on the contracts, and the municipalities as the owners of it, all kind of using the same standard set of specs. And so when you have consistency, you have less problems with communication. Everybody kind of knows that when you use a certain OPS standard, both the consultant, the contractor, and the municipality kind of know what you're talking about. It's not a set of standards that sits on a shelf gathering dust. The OPS is a very dynamic process of changing. The OPS has a very dynamic process. There are well over many communities involved in looking after many specialty areas. And over time, through successes in the field, lessons learned, input from our members. The standards are changing and evolving, as well as through legislation. And MEA and MPO is very much on top of the legislation. So something changes, you'll see those changes as well. So when you put all this together, you get a very cost effective, and I say safe because at the end of the day, if we're building standards based on our experience and our knowledge and lessons learned in the field, tried and tested, screened through a whole bevy of experts that we have on the committee, you're getting a pretty decent product out there. So what is the purpose of this training? What is the purpose of the Ontario Provincial Standards, and why are we undertaking this training? Why is MEA? Why did MEA make the effort to build this workshop or training session and deliver it? Well, so as I said earlier, we want to promote that both the MEA and the province is involved in maintaining these standards. We also want to get the word out about the depth and background behind the OPS. And really it's a lot of you may be using it on a day-to-day basis. And you just grab it, you go look at it online, you grab it, you use it, and life goes on. But I always believe it's important to understand the background. It's important to know, what is behind that standard. Who are the people behind it, and what kind of a structure and committee you have behind it. So we're trying to give people that knowledge as well. And just before I forget, if you do have questions, I believe you're typing the questions in. I always, as I do to my students, I say, please type the questions in as soon as you think about it, because it's fresh in your mind, and it'll give us a few questions to handle at the end of the session. So as I'm talking through this, if something pops in your mind, please do write the question down. I would encourage you to do so. So we're also promoting the use of the OPS. MEA and the ministry do believe that these are a very robust, very applicable set of standards. And what we want to do is promote the use of it, because surprisingly, it's amazing how many municipalities are really not taking ownership of this, or not really using it on a day-to-day basis, or using it sporadically. And until I kind of came on board, knew more about it, I would sort of scratch my head and say, why is it not being used? And I guess you start to realize, if you're not a GTA centric person, and once you get out of the GTA and you start traveling to different parts of the province, and you start to see that not everyone has the capacity and the quality of people that you get perhaps in more built up areas or more populated areas. And so municipalities, consultants, contractors, they all struggle to get really qualified people. And it's hard. It's hard when you start to go to, and when I made the move over here to Eastern Ontario, and I look at last time I worked for the counties of Lees and Grenville, we had 10 municipalities, and some of them are quite small. 7,000 people, but you know what? They still have infrastructure to look after, right? It doesn't matter. They still have roads, they still have bridges, they still have to maintain them. And so if you're going to be in the rehabilitation work, you have to get contracts out the door, and you have to have standards, and you have to have good contracts, because the problem occurs when you don't have those good standards, right? And that's why we have our documents the way they are, is to deal with the issues when the problem occurs. And you have a good backbone to step on, to rely upon, I should say, to do the work. So that's why we want to promote the use of OPS. And in many municipalities, it's a given, but however, in many municipalities, it's not. And that's why we want to promote and say, hey, come and learn about this, understand what's behind it, understand how good the product is, and question yourself as to why you're not using it. And then we're trying to show you the benefits of using it in this training session. And we're encouraging people, as we speak to audiences out there, go to the MEA site. They're always posting if they need help, if a new standard is being out there, or join a committee. I encourage all of you, my working career in that sector has ended, but I encourage all of you that are out there. This is a great way to get involved. You're with the Municipal Engineers Association. You're going to be involved in the standards, and it's a great way to network with your peers, number one, get to know people. So I really, really encourage you to look at the MEA site and look at how the committees out there. This workshop, took a bit of time to develop. We did not rush through it. Here are some of the founders of the course, so to speak. You know, we met pre-pandemic, obviously, met several times over at the OGRA offices. It was a great way to collaborate. You can see we have papers and standards all over the table. Really healthy discussion. What I want to point out here is these were developed not just from a municipal and public sector perspective, but you can see that there were other organizations involved. There was also the private sector involvement, and I thought that was very important to have that input, because we want to see the issue from both sides, not just the municipal side, but also understand that there's a private sector element to this as well. This is a general outline of the course. We went through what we do is we go through a bit of background, talk about what the OPS committee structures are like, what they're all about. We pivot a little bit, talk about claims management, dispute resolution, and how OPS can fit and help you with that. We then start to talk about, you know, where is this input going in terms of the preparation of a contract? Because if you don't have context as to where this thing fits in, it's hard to understand. One of our highlights is we have case studies, and another highlight is we go through the OPS actually online. We show people how to find the specs and the drawings, and that's one of the real, I think, benefits that we show people. And then we cover off, end it with a bit of a teaser talking about general contracts and all of the elements around a contract. So I'm going to kind of hit some of the highlights that we talk about. So we like I said before, we get into the background and the structure of the Ontario provincial standards, what the committees are, who they are, what they do, and the kind of work that they do, the process that they go through. So you understand when you know where something comes from, it gives you that confidence to rely on it. And then we really spend a bit of time and a few exercises to find specifications and drawings, because if you don't do this enough, if you're a technologist or a junior engineer or a junior staff member in a municipality or a consultant, if you don't do this enough, you're going to struggle with it. And so one of the things we do is we walk you through the OPS, and many of you probably know some of these standards, but if I had to ask you right now, right here now, go and find me where it says what the temperature of hot mix asphalt should be for binder course. You may know the answer, and that's great. But you know what? Sometimes in a dispute and a claim, it's not good enough just to know the answer. You actually have to go out there and show them on a piece of paper. And I can assure you, and I guarantee you, in many of your municipalities today, you're going down to the wire in terms of paving. I guarantee you, you're having these discussions with your contractor, you know, about paving that base course right now to get through winter. And some of you, if you don't have the right spec there, you don't have something to fall back on. And that puts you in jeopardy. It puts the contractor in jeopardy. It doesn't do any good to anybody if you didn't have that contract in there, if you didn't have that spec in there, right? So we all know the answer is 2 degrees and rising, but you know, you want to be able to find it, right? You want to be able to have it. You want to make sure it's in your contract so that when that discussion occurs, you're on solid ground, not just, well, I know it's 2 degrees and rising. Well, where did that come from? Right? So you want to know how to pull it out, how to find it, how to present it. And then reading the specs and the drawings to extract the information. The OPS is not just because you type in hot mix asphalt, you're going to find, if you type that in, you're going to find a whole bunch of references to hot mix asphalt. There could be a talk about, you know, the granulars that you use in it. There could be talk about the asphalt cement that you use in it. There could be a whole bunch of standards around there. But you got to be able to read it and intelligently understand exactly what am I looking for. And I'm going to just show you, here's a simple example that we present to our class as an exercise. We put the question that you see up top, now that we give them a little bit of a lesson on navigating the OPS, and we ask them to find some typical information. So here's a standard kind of question that we use in the workshop. Please don't share this with anybody because it is in the workshop. No, I'm just kidding. But here's something that you have to know, you know, which drawing to look up. And once you get the drawing, you have to read the drawing and understand exactly what you're looking for, because, you know, this is not something that's theoretical, right? I mean, this is, if you're you know, contractor is pouring the gutter, and you better know as an inspector or the CA, I mean, it sounds so simple, but they may not be pouring the right spec. They may not be pouring the right spec of gutter. So, make sure you point that out. Make sure you know where to look for that before you ask the question. We then delve into the specs themselves, and what we teach is, all of the specs are kind of start with the same table of contents that you see here, right? So you're seeing, and these are very similar to any spec that you go. And then you have to sort of intuitively think about, okay, am I looking for a material spec? Am I looking for a construction spec? Am I looking for something on how to measure for payment? And what is the basis of payment? So you want to know these things so that when you get into it, and here's an example of delving further into that spec, and it actually tells you way more detail, and we provide and show the amount of detail. If you just refer to, the spec 353, then you've got all of this amazing background behind you, so that if there's any questions or claims or disputes, you can fall back on this, and you don't have to worry just by making reference. That's big. And I mentioned this one earlier. And again, if you know hot mix asphalt, it's Muni 310. You might know that, you might not know that. You might need to find this spec. So how do you find it? Where do you look for? How do you find it online? How do you have this amazing encyclopedia of information at your fingertips to use that has been tried, tested, and true, has gone through the ringer, and has stood the test of time? Doesn't mean it doesn't change, and it doesn't mean as a municipality you don't change. We also talk about some other elements around OPS. We talk generally about the contract structure. So where does OPS fit in to that? We talk about the front end documents to the contract. We talk about other elements in the contract, the importance of change orders, contemplated change orders, and why they're important, why documenting them. And many of you might know that I work for Salim, and when I had to go and talk to him about, getting more, more budget, if I had my change orders lined up, if I had everything showing, and in York region had some of the, really best guidelines for change orders. If you had that behind you, it was a simple case, right? If you didn't, Salim would ask you 20 questions. Okay, and he wasn't going to let go until you got a satisfactory answer. So, the point is, do your documentation, and there are other elements that make a successful contract, right? Amending the OPS, yes, these are a great set of standards, but many large municipalities have, like City of Toronto, for example, have their own specs. And there's nothing wrong with that. Just be careful when you do them, that you do indeed get a bit of a screening. You take it through your legal if you need to, if you take it through your purchasing people. You don't want to do it willy-nilly because it can get you in trouble if you change that spec and then it's not backed up and supported by other people in your municipality. And then at the end of the course, we talk about some changes to the OPS documents. We bring forward the latest changes so everybody gets up to speed on how this is handled. One of the highlights for me in this course are the case studies. We had Joe Accardi from Accardi Schaefer's come and speak to us, and he spoke about a project in Markham on Bullock Drive, where they did a design assuming the sewer was going to be in one place, and then they had problems, and how are they going to change this in dealing with the contractor? Well, they were in for a lot of trouble, but Joe was able to rely on the OPS specs, and the contractor was agreeable to use those specs and refer to them, and they were able to negotiate and work their way through a very difficult situation because they came across something unexpected in the field despite best efforts. Many of you know Gary, a former president of the MEA. He's one of our speakers, and he talks about a project when he was at the city of Oshawa, and he actually walks you through an entire contract document with drawings and specs, and he showed in his case study, how he integrated and how the OPS is integrated. And he also did a nice explanation of how the city of Oshawa, with the amount of experience they had, how they amended some of their specs. So they had city of Oshawa specific specs out there as well. So these are some of the key speakers. We had our most recent speaker, Enrico. Many of you may know him through the industry. And Enrico came and spoke about his association and spoke about how the members of his, so the Concrete Pipe and Precast Association, the Canadian Concrete and Pipe and Precast Association. It's a mouthful, Enrico, if you're out there, but I think I got it right. And anyways, his association represents a number of manufacturers of these products that we all use on our projects out there. And he gave a great demonstration of how they, when they are in the shop, when they are in the factories, when they're engineers, when they're doing shop drawings, how they refer to so many specs when they make their product, and how they amend specs very carefully, because not everything they do is exactly as per the OPS, in terms of sometimes they have to make products that are a little bit different. So he gave a great example. So I think these case studies really resonate with our audience. We've got, and we're constantly looking for people. So if you're interested, please do reach out, because we're going to be always looking for it. So we've had 3 sessions to date, fairly successful. Our first one, our inaugural one was about this time last year. We did another one in the spring earlier this year. We did just finished our 3rd one, order of magnitude, 60 to 7 attendees. And what was really nice when we polled the audience was the range of experience. So when we polled the audience, we found there were people with less than 5 years experience, but there was also people with 20 years experience. And at first I was a little surprised, given that this was an OPS 101 course. But however, when we asked a few questions, some of the more experienced people were there because they wanted a refresher, because they'd learned this a long time ago. They've been using it in the field, but they're not exactly up to speed. They're not as technical in terms of where to find the information. They're not aware of all the changes. And so they wanted to come and get that refresher, so they're in a better position to do their job in the field. And we, for the most part, our last session, I think we had about 75% of the people were municipal staff. And we want to continue to reach out to the private sector, the consultants who work on behalf of municipalities. And we really want to get out to that contracting industry, because at the end of the day, the more knowledgeable we are about our specs and information, the easier it is going to be to resolve issues and disputes and claims and things like that, because we're all on the same page. So where do we go next from here? I think we've done a great job of setting the building blocks, as we call it, the foundation upon which your standards are based, your specs are based, what is the principle behind it. And then I think we want to look at the development of future courses that are going to be related to, we always do a little bit of a teaser on contract preparation, but we're going to get more into developing good contracts that have similar, are consistent, that have good front-end information, that are relied upon good data, field collection, good input from the designers, bid forms, electronic bidding, how to deal with those matters, and so much more around a contract preparation. Because again, just like OPS, if we start to develop good standard contracts out there, doesn't that help everybody? It helps you as a municipality. You don't have to come to a new municipality and figure out how do they prepare their contracts. As a contractor, you're going to see a similar contract wherever you bid. And as a consultant, it helps you prepare contracts for municipalities as well. So that's kind of where we're headed for that, but we do want to hear from you. Please go to this site, the Municipal Engineers Association site. There's always information there about the OPS and other things that are happening. There's a means email there if you want to contact them as well directly. I would encourage you to go see what the next course is. Please spread the word about this course. We want to get more people involved. Spread it to your contractors, your consultants, if you're in the municipal sector. I think it's a great way to get started. And of course, more courses to come on that. So that's it for my presentation, Salim. And I'm happy to pause there. It's the last one of the day. So I think I finished right on time. And we'll see if we have, if we tweaked any minds here, Salim.
Thank you, Arup. Just to let you know, they wore me down. I don't ask that many questions these days. I just sign. So
awesome.
Just to add to Arup what you said about the work on the OPS and all the committees that the MEA has. We are so thankful for all the volunteers who volunteer their experience, their expertise, most of all their time to working on those committees to keep updating the OPS so that every year when we start the season we have the best information available in terms of the OPS specs available to the entire community, and it is free. So yeah. So, and again, tomorrow there's going to be a presentation. Sorry, not tomorrow, Wednesday, presentation on the EC and MEA combined consulting agreement. Again, for those, municipalities who want to have these documents so that they can incorporate them into their contracts. I don't have actually any questions. I'm going to look to Dan. Dan, any questions from the floor?
Not yet, but I would like to make a comment in that, we started thinking about this training course many moons ago, and it took us quite some time to get the course out and available for our members and other consultants, contractor staff. We had a good mix at these courses. I'm glad that Arup mentioned the experience level that was have attended the meetings so far, the training courses so far. We always thought we were going to be getting just the juniors coming in, like the new people in an organization, be it municipal, contractor, or consultant. And yet, as Arup has indicated, there's a really good mix in terms of who's attending these courses. And, it does make sense for us to take the logical next step to evolve. I think the OPS 101 will always continue because you're always going to have that segment of employees that are coming into an organization and got to learn from first principles about all this. But we need to also adapt and get more into the contract preparation. I think that's something that's going to be really well received out there. I also just wanted to say that Arup has used a lot of information from the training course in his presentation today. The MEA and the MTO play a huge role in OPS, but I just also would like to say that there are some other partners that are involved at the OPS advisory board level. We do have organizations such as the Ontario Good Roads Association, Ontario Road Builders Association, the Ontario Sewer and Water Main Construction Association, and we also have a representative from the City of Toronto, being the biggest municipality in Ontario. So while we see ourselves as co-owners with the MTO, we do have these partners that are help us, not just at the advisory board level, but also at the committee level. We do have a question that's come in. I'll read it as it's written. Perhaps the OPS training can include the Muni 100 general conditions, which is an important component of a contract. That comment came in from Mohan Tour from Oshawa. Sorry, City of Vaughan. My apologies. My colleague here in the room corrected me quickly. Sorry, Mohan. That's a comment. Don't know if you want to expand on that, Arup.
No, always good to hear from Mohan. He's a very important part of this of OPS. He's involved in the committee structure there. I think it's a very valid question. I think Amin was talking about MPO running a session on the general conditions. And the general conditions really do lay the base for so many things. Like, you'd be amazed when you're dealing with an issue out there, how much of it comes back to general conditions. So I think that's a really, really excellent suggestion, and something we have to take away and think about. Where does that fit in? Does it fit into the next course that we're thinking about? Is it an add-on to this? So Lauren, thank you for that input. And you're right, those general conditions lay such a foundation for pretty well so many things. So many things are covered under GC. It's amazing.
Okay, thank you so much, Arup, on behalf of the MEA, again, not only for working on this course in order of preparing the course, but also delivering the course for us. So thank you so much, and thank you for today. Coming and presenting today. So on behalf of the MEA, thank you, and we'll be sending you a gift certificate, the token of our appreciation. Thank you.
Much appreciated. My pleasure.
Okay, we are 3 minutes beyond, respecting people's time. I'll quickly run through a couple of things. So thanks again to Concrete Ontario, our platinum sponsor for today. And I also want to acknowledge all our sponsors, the bronze, silver, gold, and platinum sponsors. Again, please, when you get time, always available. If you can go to the virtual booths and please visit the sponsors. And again, not taking too much time, want to remind everybody that the next session will be on Wednesday at 9 o'clock. And we'll see you then.